Finally, some real answers to the extinction of cave bears, megafaunal extinctions during the Ice Age. We're getting some really cool information here. I've not seen any news on this. I saw this on Twitter with a Twitter thread. I meant to include that Twitter thread in the citations below. I'll add it afterwards. Written by the lead author, Jennifer Jones, who got her PhD here at Cardiff. She's a fantastic individual, and her handle on Twitter or X is Jennifer Bones. So, she's great. Yeah. And so this research is phenomenal. I'm really interested in this. This is an isotope analysis, so a molecular analysis of the diet of cave bears in Serbia, in a site from Serbia, Salitrena Pecina. I'm not sure if I'm pronouncing that right, which dates to about 40,000 to 37,000 years ago. So at the time when cave bear populations were starting to dwindle, they don't end up going extinct for another 15,000 years, and we'll get into that in a second. And this looks at their diet to try to answer these questions. So what is a cave bear? Cave bears are now extinct. They're very large bears. They probably would have been quite frightening, but as you'll see, they probably wouldn't have eaten you. So this is a skeleton from the Field Museum, and this is a reconstruction that is available online. They're quite large, and they would have been probably pretty frightening, but they're pretty cool animals. It would have been one of the animals that would have competed for space in rock shelters and caves. You need some shelter during a glacial snowstorm in the Ice Age as you're trekking around and you get to a cave and, oops, it's inhabited by a cave bear. Okay, so there's a lot of debates right now over the extinction of megafauna. We oftentimes hear about this debate in the Americas, but this is a pattern and a trend that occurred in the later parts of the Ice Age, in the later parts of the Pleistocene, all over the world. From Australia to the Americas to Europe to elsewhere. And cave bears are part of this trend of megafaunal extinction. The last cave bears that are found are from northern Italy from about 19,000 years ago, but they started dwindling their populations around 50,000 years ago. And so it was a slow process of extinction. And the debate is, well, there's three different options that people have come up with. Climate change, that's an important one because obviously this is around the time of the glacial maximum. So when things are extremely cold, right, that's going to impact the flora, the fauna, the hunting, if they're hunting, things like that. Perhaps it was carnivores, including humans, maybe Neanderthals, that were hunting them, and that hunting slowly led to attrition. And after all, if these cave bears are in caves that maybe you want to shelter in, maybe you're going to figure out how to slaughter them and eat them. And we have evidence of butchered cave bears, as well as dietary inflexibility. Could cave bears adapt to changes in the climate and in the vegetation and in the flora and the fauna around because they were not very resilient to changes that were going on? So this study is designed to answer this kind of question. It is this cave located in Serbia, and they tested, I'm forgetting how many individuals right now. We'll show it up as dots on a graph, and they tested them to look at their diets to understand what they were eating. And to do that, they did a molecular analysis of isotope ratios of carbon and nitrogen. In a sense, I do this with animals as well. I do this with goats, and I've explained it before on the channel. If you look at my second big archaeology stream, I describe some of my research, for example. And so what we're looking at here is nitrogen tells you how much animal protein an animal or an individual consumes. And interestingly, cave bears were not carnivores. Cave bears had a fairly herbivorous diet. So this graph on the left, this compares the diets of cave bears, which are these blue dots. So there's 2, 4, 6, 7, 8 of them that have been compared with other animals, specifically herbivores, at the exact same site. And notice that they all fall in with a similar range. And none of them have a very high nitrogen ratio. If these cave bears were carnivores, they'd be way up here in the upper left or upper right or upper center. They'd be at the top, and they are not at the top because they are eating mostly an herbivorous diet. So they are eating mostly plants rather than animals, because cave bears were mostly plant eaters, actually. So you don't have to worry about cave bears hunting you. You just might not want to disturb a mama bear and go after her cubs, because then you might have some issues. So they actually line up fairly well, but there's a lot of diversity, if you can tell. They range across what kind of plants they're eating. And that's what the left to right axis, the carbon isotope ratios, tell us is the types of plants that they're eating. And there's a sort of diversity, a range to this, which is really cool. It shows that these cave bears had a fairly diverse diet of the plants that they were consuming, which if you then start mapping it out, so the big red triangles on here are the cave bears from this site, while the rest of these dots are cave bears from other sites. It shows that it maps out fairly well, but also demonstrates we can see some outliers, for example, from this purple site, which is from Romania, which led to a huge debate about cave bear diets and things like that, as well as this individual outlier from this site, for example. Cave bears actually had a very wide range of plants that they were consuming. And so they were somewhat resilient. So they did not have a kind of limit to the plants. They could adapt to the changes in environment that were happening around them at this time by consuming a different range of plants. And we see that at individual sites as well as comparisons across sites, which is pretty cool. It shows the kind of resilience here. And so what this tells us is that although the diet of cave bears was predominantly herbivorous, it was not homogeneous. So it was not the same through time. And it shows they were able to adapt and to be flexible with the local conditions that were changing around them. And so this really matters. What this tells us is that cave bears were able to adapt. So it is likely that climate change might have had an impact, but it's certainly the changing in vegetation was not the only thing. We have to understand that probably there's an impact of human impact as modern Homo sapiens are moving in. This matches that exact same time. And at the same time, the glacial maximum would have led to fewer and fewer resources available for the competitions between different species, whether it's cave bear or aurochs or Neanderthals or Homo sapiens. They're all competing from the same pool to be able to gather plant food that's available. And so that's what we're looking at here, is that they are able to adapt. And so Jennifer, Dr. Jones, has pointed out that both on Twitter and her thread and at the end of the article, that this is actually something that can inform us a lot. Maybe this is a parallel to the extinction of Neanderthals, who went extinct at a similar period of time as the cave bears, that also perhaps were able to be resilient and adapt in their diet. There's still more studies of Neanderthal diet that need to be done, but this sort of limiting of niches and ecosystems and availability of foodstuffs, that would have been one limiting factor, in addition to the introduction of a new species, modern Homo sapiens. And there's one last lesson to learn, which is we need to apply this today. Today, we are worried, very worried about the extinction of animals. And for example, modern bears are fairly resilient as well. They have shown that they can adapt to various niches as they experience habitat loss. But as we can see, cave bears were also quite resilient with their dietary adaptations, and they still ended up going extinct, even if it took them tens of thousands of years from their peak population size to their dwindling population size to extinction. And this photo here, for example, is a photo of Dr. Jones volunteering with the Cantabrian Brown Bear Society and planting fruit trees to provide food for endangered bear populations in Cantabria. And so this is really important. We need to do what we can to protect local biodiversity. Okay, what's up next? Are you tired of all the news? There's just so much going on in the news. Like, look at the size of this ancient Roman shoe. This is what we're here with for old news with Flint Dibble. We're gonna look at this shoe that apparently perplexes archaeologists. Or does it?
We're not perplexed at all, in fact.
Beyond that, we're going to look at how shifts in the magnetic poles tens of thousands of years ago that ancient humans and Neanderthals adapted to. Or what about the Antikythera device? Is it a computer?
Had to rethink the history of technology completely as a result of this single object.
We're going to look at the shipwreck that it's from. And finally, we're going to check out some of the most amazing boar feasts that ever happened 10,000 years ago in Southwest Asia. Stay tuned for the very first episode of Old News with Flint Dibble. And I'm Flint Dibble. See you soon.